rhombi and squares. All right, refer to the rhombus FGHI if EK equals 5. Let's find EK. Well, that's FK, isn't it? FK. If FK equals 5, where did I get EK from? If FK equals 5, so this is 5, and FG equals 13, there's 13, find KJ. So this is what we're trying to find. We'll put it on the other side. And that's what we're curious about. What is KJ? Well, one of the properties of a rhombus, which is the singular version, or the plural, the singular version of rhombi, which is plural, of a rhombus is that all of its sides are equal. And another characteristic of a rhombus is that the diagonals form they are perpendicular, which if that's the case, then this is going to be a 90-degree angle. Now, if all the sides are congruent, then that means that FJ has also got to be 13. If FG is 13, FJ is 13. And if this is a right angle, this is the hypotenuse. And so I think I could use Pythagorean to find KJ, because I know one side, which is FK. I know another side, which is FJ, which happens to be the hypotenuse. And I got a right triangle here because those two diagonals are going to be perpendicular. So let's set this up. So let's say then that we're going to call KJ A. How about that? A squared. Let me change that back to red. A squared plus 5 squared equals 13 squared. So we got A squared plus 5 squared is 25. 13 squared is 169. Let's subtract 25 from both sides so that A squared is equal to, let's see, 129 minus 25, 144. Let's take the square root of both sides. And A is equal to 12. Shazam. Which is equal to KJ. Rhombus. I just love saying the word rhombus. Here we got another one. We're going to refer to the same rhombus, but in this time we're told that the measure of JFK, that would be right here, that would be that angle right there, is 6y plus 7, and the measure of KFG, that angle right there, maybe we should put that in a different color, is equal to 9y minus 5. Find y. All right, well, let's see. Let's think about this. Another property of a rhombus is that angles such as this, what we see right here, they are going to be congruent. So these angles, in this case, what we're looking at, they're going to be congruent, so I can set that equal to each other. So let's say we got 9y minus 5 is now equal to 6y plus 7. Well, let's add 5y to both sides and subtract 3y from both sides, and then we'd have, 5y and 6y, then we'd have 3y equals 12, and divide by 3, and y is equal to 4. And there we go. We have found it. And we've looked at 3 different properties in these 2. Talked about how the sides are all going to be congruent, how the diagonals are going to be perpendicular, and the adjacent angles are going to be congruent. Adjacent angles formed by the diagonals are going to be congruent. Give me a rhombus.